Jai Hind to all of you. I am Kumar Jaiswal, working as an assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to deliver a lecture on topic firewall and its types. It comes under the subject data encryption and compression. The subject code is the STCS 501. So, firstly, I am going to give what is the definition of the firewall. A firewall is a system of hardware and software components designed to restrict access between the internet and private network. A firewall is a security system that acts as a protective boundary between a private protected network and the outside world. A firewall is a network security device or software designed to monitor and control incoming and outgoing network traffic based on predefined security rules. This is the diagram. Here, these are the rules: who, when, what, how, and this is the internet, and this is our protected network that is called as the private network or intranet, and here firewall is present. So, a firewall primary purpose is to establish a barrier between a trusted internal network and untrusted external network, such as the internet, to prevent unauthorized access, data breaches, and cyber attacks. So it is important to know what are the steps involved in the working of the firewall. The first step is the packet reception. Second is the header inspection, then rule evaluation, deep packet inspection, this is the optional, decision that packet is allowed or blocked, session tracking, logging and alerts, and then packet forwarding. These are the main steps. Why firewalls are important? Because it implements security policies at a single point. It monitors security related events, audit, log, etc. It provides strong authentication. It allows virtual private networks. It contains a specially secured operating system. So, it is important to know what are the factors considered while designing the firewall. We can say firewall design guidelines or principles. We should design the firewall such way that all the traffic must pass through the firewall. Develop a security policy. Create a simple design solution. Use devices as they were intended. Implement a layered defense to provide extra protection. Consider solutions to internal threats that should be included in your design. Only authorized traffic is allowed to pass, and use following control techniques, that is the service control, direction control, user control, and behavior control. So, what are the components of the firewall? This is very important to understand. Network policy. In network policy, what are the restrictions required and how enforced? Second component is the advanced authentication mechanism. That is the one-time password, biometric system, smart cards, packet filtering, source destination IP address or port number, and in case application gateway, proxy services. So these are the components, important components while designing the firewall. To understand the firewall working, we should know about the OSI model. In the OSI model, there are 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer, as we know already. And the firewalls work mainly on the network layer, transport layer, session layer, and application layer. So, what are the main types of firewalls? According to our syllabus, that is the packet filtering router, circuit level gateway, application level gateway, and next generation firewall. The first category is the packet filtering router. In this diagram, here the internet, that is www, and private network, and packet filtering router is presented here. A packet filtering router is a most basic type of firewall that controls network access by analyzing incoming and outgoing packets based on a set of predefined rules. It inspects packets, that is the data units, being transferred between computers. It checks the packet source and destination IP addresses, port numbers, as well as protocol types. This is one of the simplest and oldest form of the firewall. It operates on the network layer, that is the layer 3 of the OSI model, and transport layer, that is the layer 4 of the OSI model. It works on the both the layers. So what information is used for filtering decision? Source IP address, destination IP address, that is called as the IP header, protocol type, source port TCP or UDP header, destination port, and acknowledgement bit. These are the important information that are required during the filtering decision. So how packet filtering works? The packet filtering router reviews each packet entering or leaving the network and apply a set of security rules. These rules can be based on source IP address, destination IP address, protocol, and port number. Example, if the packet filter is configured to block all traffic from the IP address 192.168.1.10 and allow traffic only on port number 80, then it restricts the any information or packet coming from the this IP address, and also restricts the any information which are coming from the other port like port number 21, and it will be denied. Some examples of the packet filtering router firewalls are the Cisco iOS firewall. Cisco routers can be configured with packet filtering firewall capability using Cisco iOS software. Another is NetFilter IP tables used in the Linux. PFSense, an open source firewall router software based on free BSD capable of packet filtering. MikroTik router OS, Sonic Wall TJ series. These are the different examples of the packet filtering router firewalls. Now, packet filtering router have some advantages. It works at the network and transport layer of the OSI model, and it's very simple. It has low impact on network performance. It is faster than other types of firewall. It is relatively cheaper in price, having the lower cost than the other types of firewall. Low resources is used by this because it only looks at the header information, so it requires less processing power. These are the different advantages. Along with the advantage, there are some disadvantages that packet filtering routers have. It provides low level of security because it does not keep track of all the state of connection, so it is vulnerable to certain attacks like IP spoofing. It lacks in tracking of connection state. It provides limited protection because it does not analyze the content of the packets, so it cannot detect malicious data within the packets. It is transparent to the user. It is hard to manage because managing large set of filtering rules can become complex over time. It is difficult to configure as compared to other types of firewall. It cannot hide the private network topology, so our topology will be shown to the attackers. It can not support all internet application. It has limited auditing capabilities. Sometimes user level authentication is not supported by this type of firewall. So another type of firewall comes into the picture, that is the circuit level gateway. This is the outside host, outside connection, out in process, circuit level gateway, inside connection, and this is the inside host. Here circuit level gateway firewall is present in this diagram. A circuit level gateway is a type of firewall that operates at the session layer, layer 5 of the OSI model. It monitors TCP, handshakes, and other protocol session, initiating message between trusted and untrusted hosts to determine that a requested session is legitimate or not. Unlike packet filtering firewalls, circuit level gateway do not inspect individual packets. Instead, they focus on that a valid connection has been established. So it focus mainly on the connection, not on the filtering of the packets. How a circuit level gateway works. For example, if a user inside the network wants to connect to an external server, the circuit level gateway will ensure that the connection establishments follow the proper protocol. A valid TCP handshake. If the connection setup is valid, the firewall allows the session to be established. The firewall does not inspect the actual content of the data being exchanged during the session created. The gateway tracks the status of the session between two hosts. When an internal host initiates a connection, the firewall monitors the TCP or equivalent session setup to verify that it is legitimate or not. Once verified, it allows the session to continue and forward the traffic without inspecting the individual packets. Some of the examples of the circuit level gateway firewalls are Cisco ASA, Adopti Security Appliance. While primarily used as a stateful firewall, it can also function as a circuit level gateway for monitoring TCP handshake. Sonic wall firewalls. Third example is the Juniper NetScreen. Fourth is the Checkpoint Security Gateway, and fifth example is the Fortinet FortiGate with specific configuration. These are the some examples of the circuit level gateway used all over the world. So it is important to understand what are the advantages circuit level gateway firewalls have. It works at session level of OSI model. It monitors TCP handshaking. It can hide the information about the private network. It is cheap in price. It is useful when administrator trusts the internal users. It provides high level of security than packet filtering router. It provides session control because it is effective at the ensuring the legitimate session and can provide additional security in conjunction with other firewall types. It does not perform deep inspection of each packet, so it uses fewer resources and has a smaller impact on the network performance. It provides a way to control access to sessions, so it allows only authorized or valid connection in session management. So it is very important in case of the session management. Along with the advantage, it has also some disadvantages. It has some impact on network performance. It is typically used with other firewalls, application level or packet level filtering firewall to provide comprehensive security for most robust protection. It does not inspect the data within the packets, so there is lack of content filtering, and it cannot detect threats like virus, malware or other harmful content embedded in the data stream. It cannot prevent attacks that occur within the session after it is established, so it provides very limited security. Third category of the firewall is the application level gateway, and these are used as the proxy server. Here proxy server is presented. These are the outside client proxy connection, proxy server connection, inside server, application level gateway, FTP, proxy in-out process, telnet, in case of telnet in-out process. So this is the complete diagram of the proxy server or application level gateway. An application level gateway, in short it is known as the ALG, also known as the proxy firewall, is a type of firewall that filters incoming and outgoing traffic at the application layer. Application layer, that is the layer 7 of the OSI model. It acts as an intermediary between user and the services they wish to access, and it inspects the data for specific application such as HTTP, FTP or SMTP to provide enhanced security. It also acts as an intermediary between end user and the destination server. Instead of packet directly passing through, the proxy firewall establishes a separate connection to the destination on behalf of the user. How an application level gateway works. For example, if a user tries to access a website, the user request is sent to the ALG. The gateway checks for supervisor or malicious content blocks and any unauthorized request, and forward legitimate traffic to the website. The response from the website goes back to the gateway before reaching the user. Some of the examples of the application level gateway firewalls are Fortinet, FortiGate, Alto Network Next Generation Firewall, NGFW, Sophos XG Firewall, Checkpoint Firewall, Cisco ASI with Firepower. Now I am going to discuss about the advantages and disadvantages of the application level gateway firewall. It works at the application layer of OSI model through filtering. This was the first advantage. Second, it provides higher level of security than packet filtering router. This firewall understands the application protocol, so it can detect and block dangerous requests within the protocol. It examines all traffic in detail, so slower than packet filtering router. It is easier to configure than packet filtering router. It can hide the private network topology. It supports user level authentication. It can be used to filter undesirable content like blocking certain websites or types of content based on the policy. So it provides content filtering feature. This is a very important feature that application level gateway has. Now, disadvantages: it has high impact on network performance. It is slower in operation because of processing overheads. It is not transparent to the user. It requires more complex rule setup and management compared to lower level firewalls. ALG are tailored to specific application and may not work for all protocols or services. So these are the disadvantages. Now, next generation firewall. In short, these are called as the NGFW. This is the internet next generation firewall. This is the campus network. Here World Wide. This is the simple diagram how NGFW is placed. A next generation firewall is a type of firewall that goes beyond traditional firewall by integrating advanced security features like deep packet inspection (DPI), application awareness, and the ability to detect and block modern threats and attacks such as malware and intrusion. NGWS can be deployed on premises or in the cloud. They can be managed centrally or within Unbox Manager. So, if we are talking about the cloud, then these firewalls work at the cloud system also. That they are also called the cloud firewall. NGFW is a network security device that combines a traditional firewall with other network devices filtering function. NGWS operate across multiple layers of the OSI model to provide comprehensive security. It may work on layer 3, 4, 5, and 7 of the OSI model. This is the NG firewall, next generation firewall. Block file symbol, allow file symbol, next generation firewall, next generation malware protection, next generation IPS, on box. So this is the working of new generation firewall. A next generation firewall is a type of firewall that goes beyond traditional firewall by integrating advanced security features like deep packet inspection. I already explained this. So what are the key features of next generation firewall? The important feature that NGFW have, this is the deep packet inspection. In short, this is called as the DPI. Application awareness and control. Integrated intrusion prevention system, IPS. This is the next generation IPS. Threat intelligence, SSL, TLS decryption, user identity awareness, advanced malware protection. These are the key features of the firewall. Now, some of the examples of next generation firewall are Fortinet, FortiGate, NGFW, Checkpoint NGFW, Sonic Wall NS series, Alto Network NGWF, So for XG firewall, these are the some of the examples of the next generation firewall. So how these firewalls provide the deep packet inspection. NGWS analyze the full content of data packets, not just the header, allowing them to inspect traffic at a deeper level for threats rather than just filtering based on IP address and ports. Application awareness and control. NGFW can identify and control application running on a network regardless of the port they use, and allowing more granular policies. For example, you could allow HTTP traffic only from certain applications like Slack, white block, others. Integrated intrusion prevention system. NGFW include intrusion detection and prevention system to block malicious activities by inspecting traffic for known attack patterns and vulnerabilities. Threat intelligence. NGFWs can leverage real-time threat intelligence from cloud service to identify and block new and emerging threats such as zero-day exploits. SSL TLS description. NGWS can decrypt and inspect SSL TLS encrypted traffic to detect hidden threats or malware in encrypted session. User identity awareness. It is provided as a when integrate with directory service like Active Directory to apply security policy based on the user identity, roles and groups, and adding another layer of security beyond just IP addresses. Advanced malware protection. Some NGFWs integrate antivirus and sandboxing technology to detect and prevent malware infections. So these are the important key features of the next generation firewall. The working I already explained and the introduction I given. So it is all about the next generation firewall. Mainly it is based on the cloud environment, and these are the references which I have used while making this lecture. Thank you very much. If you have any query, then feel free to contact me. My email ID is given here. Jai Hind and thank you to all.